Hello everyone and welcome back to my YouTube channel. In today's video we have something that everyone has been waiting for. We will cover all of middle school math in just 30 minutes. Make sure that you watch the video till the end, and after this video you'll know everything that a grade 8 or even grade 9 student is supposed to know to move on to a high school. In this video, we will cover the following topics. We will start with positive and negative numbers and all the operations between positive and negative numbers. Then working with decimals, fractions, mixed numbers, then percentages, expanding like terms, factorizing and basically simplifying expressions, solving equations and inequalities, ratios, rates, proportions. Very important topic, slope, finding x-intercept, y-intercept of a line, and then a bit of geometry, angle, relationships with angles, areas of common shapes. And of course, we will end with the Pythagoras, the famous Pythagorean Theorem. Make sure that you like the video, subscribe the channel, and let us begin. Alright, positive and negative numbers first. So, we all know how to start with positive numbers, right? If I say, for example, 3 plus 4 plus 7, that is equal to 3 plus 4 is 7 plus another 7, that is equal to 14. Now, what about order of operation? If we have, for example, 3 times 4 plus 12 divided by 3. Now we follow the priorities. Multiplication and division have higher priority, so we do that first, right? 3 times 4 will be equal to 12, plus then 12 divided by 3 will be equal to 4. Oh, and then we have 12 added 4, which is equal to 16. What if we have brackets? One of the most common mistake. If we say, for example, 5 minus, and then in brackets we say 3 plus 4. Again, brackets have our priority, right? So we do that first. It's going to be 5 minus, and then 3 plus 4 is equal to 7. Oh, we have 5 minus 7. Now, let us zoom it in. Our number 5 is positive, right? So we have a positive 5 and a negative 7. Then you can say, is it more positive or more negative? It's more negative. Negative how much? Positive 5, negative 7 will be equal to negative 2. And with that, we start with negative numbers as well. If we say, for example, negative 4 and then negative 3, what do we have this time? Both of the numbers are negative, so the result will be negative, of course, because we are adding them. If we have negative 4 and then we have negative 3, in the end we end up with negative 7. Alright? But what if we have, for example, negative 15 and positive 10? In this case we say, negative 15 and positive 10, so our number will be negative. It's more negative than positive. By how much? What is the difference between them? 15 and 10, the difference between them is 5. So the answer is negative 5. And what if we have some brackets involved? 12 minus and minus 3. Now you have learned that two minuses next to each other will make it a plus. So basically this becomes 12 plus 3, which is equal to 15. And then in this case, again, get rid of the brackets first. Plus and minus next to each other will give us a minus. So we have negative 15 and negative 4. And then we learned already, negative 15 and negative 4, the answer will be negative for sure. But negative how much? 15 and 4, it will be negative 19. And then we start with multiplication and division. Now what is important? Whenever we have to multiply or divide two numbers, when one of them is positive, one of them is negative, or both are negative, then you can follow the order. If you have plus and minus or minus and plus next to each other, they will always give you a minus. And then if we have two positive signs or two negative signs, it will always be a positive answer. Now, how does that work? If we say, for example, 4 multiplied by 3, both of the numbers are positive, so the answer will be positive 12. You do not have to write the plus sign. But if we have, for example, negative 4 multiplied by 3, one of the numbers is negative, so the answer will be negative. And then 4 times 3 is 12. Now, what if both of them are negative? For example, negative 4 multiplied by negative 3. We said if both of them are negative, the answer will be positive. So it will be positive 4 by 3, which is equal to 12. Now, to finish it up, let's have one question that completes both addition, subtraction, and also multiplication and division. And here it is. So we have a question that has basically everything. But then following the order of operation, we know that brackets have priority. So we will do this first and this as well to remove the brackets. It's very important that you write step by step. So negative 12 divided by. What do we have in brackets here? 3 minus minus 1. We just learned that that will turn into plus. So 3 plus 1. And then we have plus negative 2 multiplied by negative 3. We just learned that it is equal to positive 6. Are we done with the brackets? Not yet. We have this one here. 3 plus 1 is 4, right? So we have negative 12 divided by 4, and then we have plus 6. Finally, division has priority. So negative 12 divided by 4 is equal to negative 3, and then we copy plus 6. In the end, we ask, is my final answer going to be more positive or more negative? The answer will be more positive, right? How much more positive? What is the difference between 6 and 3? It is 3. That's it. We are done with the first chapter. Now to decimals. So, when we talk about decimal numbers, it's very important that we know how to add, subtract, and how to multiply and divide decimals. If we have to add them, for example, 3.51 plus 4.82, it's very important that whenever we have addition or subtraction, we align the decimal numbers. So, for example, 3.51 added to 4.82. And then we start. 1 plus 2 is equal to 3. 5 plus 8 is equal to 13, so 3 and 1. Here we have point, we copy the point. 1 plus 3 plus 4 is equal to 8. That's it, we are done. But what if we have to subtract them? So for example, 4.8 minus 3.51. Then in that case, we would say 4.8 minus 3.51. We still have to align the numbers. Now we see there is one missing here. If you want, you can write a 0 to make it easier. And then we do normal subtraction. 0 minus 1 doesn't work. So we have to trade. We get 1 from 8. 8 will become 7. But then our 0 will become 10. And then finally, 10 minus 1 is equal to 9. 7 minus 5. It works. It is equal to 2. Point, we have to copy that. And 4 minus 3 is equal to 1. Perfect. That is how we add and subtract decimals. Now, how does that work with multiplication and division? When it comes to multiplication, I find it pretty simple. Forget about the decimal point. You basically have only 5 multiplied by 24, and then it's normal multiplication. 4 by 5 is equal to 20, 0 and 2. 4 by 3 is equal to 12, plus 2 is equal to 14. Put the 0 down, do the same thing with number 2. 2 multiplied by 5 is equal to 10, 0 and 1. 2 by 3 is equal to 6, plus 1 is equal to 7. Add them up here. So we get 0, 4, and 7 plus 1 is 8. Then we go back to the original question. How many decimals were after the decimal point? How many digits? Here, 1 digit. Here, 1 digit. Altogether, 2 digits are after the decimal point. So we can basically move the decimal point twice. And the final answer will be 8.40. Now, a very important rule. 0 in the end is called a trailing zero. So you can basically only say it's 8.4. That's it when it comes to multiplication. The last one is division. Now, when it comes to division, we in math do not divide with a decimal number. So what we basically do is, how will I multiply my 0.2 to make it a whole number? If I move the decimal point once, that basically means I multiply that by 10. But whatever you do to the right side, you must do to the left side as well. So we must multiply this one by 10 as well. Oh, so what does that become? 4.8 becomes 48. 0.2 becomes 2. 48 divided by 2 is equal to 24. And that is the answer. 4.8 divided by 0.2 is equal to 24. Do not be confused. Whenever you multiply or whenever you divide by a number that starts with 0, then your number gets bigger. So 4.8 divided by 0.2 becomes 24. Now, if you had to multiply, for example, 4.8 by 0.2, then your number doesn't get bigger, it gets smaller. So multiplying by 0.2 will make it smaller. Now, it's a normal multiplication, the one that we just talked about. You would multiply 48 by 2, and then you would move the decimal point twice. That's it. We move on to the next chapter. In this chapter, we talk about fractions. Now, when we say fraction, it is basically part of a whole. So if we say 1 out of 7, that means that out of 7 parts, 1, 2, 3, 4, 5, 6, and 7, we have 1 part only, right? So it's 1 out of 7. Now, the fraction that we see, 1 out of 7, or for example 2 out of 5, or for example 3 out of 11, and so on, these fractions are called proper fraction. The reason for that is because numerator is smaller than denominator. And then the same logic applies here. If we have fractions like 3 over 2 or 7 over 4 and so on, then these fractions are called improper fractions because the numerator is greater than denominator. Now, what if we have fraction and we need to write it as a decimal number? For example, if we have a fraction, let's say 3 out of 10. Now, you can either write that this is immediately 0.3, or basically if you just divide 3 by 10, then you would get a decimal number. Let's test it out. 10 into 3 fits 0 times. 0 by 10 is 0. We add a point, we add a 0 here. 10 into 30 fits 3 times. 3 times 10 is 30, and the answer is 0.3. That's it. So every fraction can be converted into a mixed number by just dividing numerator by denominator. And then the other way around, if we have a decimal number, for example 0.45, to write it as a fraction, the only thing we do is we copy all the digits that we see after the decimal point. In this case, it's 4 and 5, and then you put 1, and then you add as many zeros as you have digits after the point. We have 2 digits here, so we would add 2 zeros here. Basically, that's it, we are done. Now, we will learn later that every fraction, if possible, have to be simplified. So for example, 45 and 100, both can be divided by 5, right? And 100 divided by 5. 45 divided by 5 is equal to 9. 100 divided by 5 is equal to 20. 9 over 20 is this fraction in simplest form. And by the way, it's a proper fraction. Now, let's learn how to convert fractions into mixed numbers. If we have a fraction, for example, 10 over 3, remember, we call it an improper fraction. Now, the improper fractions can always be written as a mixed numbers. What does that mean? You basically ask yourself, How many times does 3 fit into 10? It fits 3 times. We have to copy our denominator, and then 3 multiplied by 3 is equal to 9. How much more do I need to reach 10? Oh, it's only 1. So the final answer will be 3 and 1 over 3. This, what we see, is what we call a mixed number. A mixed number that has a whole number and a fractional part. Now, what if we have the other way around? For example, 4 and 2 over 5. How do we write this mixed number? How do we convert it into a fraction? It's pretty easy. We start by copying the denominator, okay? 5 remains 5. And then we have a circle that says 4 will be multiplied by 5 and then added to 2. What is 4 times 5? 20. 20 plus 2 is equal to 22. Oh, so our final answer is 22 over 5. Finally, how do basic operations with fractions and mixed numbers work? So, let us start with fractions like this. What we notice is that fractions have same denominator. Remember, whenever adding or subtracting fractions, they must have same denominator. If they have same denominator, easy. Copy your denominator and then perform the operation. It says 1 plus 2, right? 1 plus 2 is equal to 3. That's it, we are done. Here, they do have same denominators. We copy our denominator and then 3 plus 4 is equal to 7. Remember, this is an improper fraction. It can be written as a mixed number. We have just learned how. It will be 1 because 5 into 7 fits once. We copy 5. 1 times 5 is 5. There is 2 left. Same thing works with subtraction. If we have, for example, 8 over 11 minus 3 over 11. 11 is their denominator, so it remains the same. 8 minus 3 is equal to 5. And it is a proper fraction in simplest form. What if we have multiplication and division? Or before that, what if we do not have same denominators? In these two examples, we have to add or subtract fractions that do not have same denominators. You have to do something. You have to find the lowest common denominator, lowest common multiple for the denominators, so that you can add them. Now we notice here that 5 can be multiplied by 2, so that we have 10 and 10, right? But if you multiplied 5 by 2, do not forget to multiply 1 by 2. So that turns into 3 over 10 and then plus 2 over 10. They do have same denominators now. So 3 plus 2 is equal to 5 over 10. Do not forget, this can be simplified. Both can be divided by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. That's it, we are done. Same thing here. We need to subtract them. But what is the lowest common denominator here? We notice that 3 and 4. Number 12 is divisible by both 3 and 4, right? So multiply by 4, multiplied by 4, and then multiplied by 3 and multiplied by 3. What does it become then? 2 by 4 is 8 over 12 minus 1 by 3 is 3 over 12. Now we have same denominators. 8 minus 3 is equal to 5 and 12 remains the same. This answer is already in simplest form. Finally, what if we have multiplication and division? Keep in mind, for multiplication and division, we do not need same denominator. So for example, 3 over 5 multiplied by 1 over 4. The only thing that you have to do is numerator by numerator, 3 multiplied by 1 is equal to 3, and denominator by denominator. 5 multiplied by 4 is 20. So the final answer is 3 over 20. That's it. No common denominator needed. What if we have division? For example, 3 over 5 divided by 1 over 4. Now for division, it doesn't work. There is something that we call keep, change, flip. That rule can be used whenever we have to divide two fractions. What does that mean? Keep the first fraction as it is. 3 over 5, keep it as it is. So 3 over 5. Change your division into multiplication. And finally, flip your numerator and denominator, so 1 over 4 will turn into 4 over 1. Now we have basically just a multiplication. 3 multiplied by 4 is equal to 12, and 5 multiplied by 1 is equal to 5. Again, this can be written as a mixed number. We already learned how. 2 by 5 is 10, 12 minus 10 is 2. That's it, we are done. Now let's see how that works with mixed numbers. Basically, same rules apply here. If we have, for example, 5 and 1 over 4 added to 3 and 2 over 5. Again, our focus is same denominators. Now, what's the LCM for 4 and 5? We notice that number 20 is divisible by 4 and 5. So, multiplied by 5, by 5, by 4, by 4. And then this turns into 5 and 5 over 20 plus 3 and 8 over 20. Finally, we add the whole numbers first. 5 plus 3 is equal to 8. Denominator stays the same. We just add the numerators. 5 plus 8 is equal to 13. That's it. We are done. Now, what if we have subtraction? If we need to subtract, for example, 5 and 1 over 4 minus 2 and 2 over 3. Again, the first step would be make same denominators. We have learned it already. So it will be 5 and then times 3. It becomes 3 over 12 minus 2 and times 4. It will be 8 over 12. But now if you try to subtract 5 minus 2, it's fine, no problem. But 3 minus 8, it doesn't work. So we have to trade. Now, if we get 1 from 5, then 5 will turn into 4. But that 1 that we took from 5 can be written as 12 over 12. So basically, add your 12 over 12. Or what you can do is just turn this into plus. And you get 4, 3 plus 12 is equal to 15 over 12 minus 2 and 8 over 12. Finally, 4 minus 2 is equal to 2. That's fine. 12 remains the same. 15 minus 8 is equal to 7. That's it. We are done. So please, if this was unclear, you should watch it a couple of times to revise this part. When it comes to multiplying or dividing mixed numbers, then we have to write them as improper fractions. So remember, 4 times 3 is 12 plus 1 is 13 over 3 times 2 times 5 is 10 plus 1, 11 over 5. And then there is nothing to be simplified, so we just have to multiply. 13 by 11 is equal to 143. 3 by 5 is equal to 15. Remember, this can be written as a mixed number again. That's it with this chapter. We move on to the next one. Alright, then we move on to the next chapter, percentages. So basically, if we have 5% and we want to write it as a fraction or as a decimal number, the only thing that we need to do is make it out of 100, because percentages are always out of 100, and then 5%. 5 out of 100. Alright, and then as a decimal number, it will be 0.05. That's it. If we have 12%, we do the same thing here. It's out of 100. How much out of 100? It's 12. And then as a decimal, it will be 0.12. Excellent. Then we have the next one, 40%. Still, we make it out of 100, right? So, how much out of 100? It's 40 out of 100. Now be careful with this one. It's not 0.04. It's 0.4. Or basically, if you want, you can say 0.40 as a decimal. 100%, still, it remains the same. It's 100 out of 100. But then as a decimal number, it's 1. Excellent. And the last one, logic remains the same. How much out of 100? 150. 150% as a decimal will be 1.5. That's great. Now, how do we find percentages of a number? So if we need to find, for example, 10% of 400. Now, I'm sure that most of you can do this mentally, but let's see how that works. If you write 10% as a fraction, it will be 10 out of 100. Now, of is always used as multiplication. 400 can be written as a fraction as well, 400 over 1. Alright, we can simplify this. How do we simplify this? 1 0 up, 1 0 down, 1 0 up, 1 0 down. Oh, so we basically have 10 multiplied by 4, which is 40. So 10% of 400 is equal to 40. And one of the best trick with percentages, imagine you need to find 16% of 25. What you can do basically is just swap them, because this is not easy to be found. But what if you swap them and you say basically, what is 25% of 16? What is that? 25% is 1/4, right? So you can either say 25 out of 100 multiplied by 16, or if you simplify this, then you can say 1/4 of 16. Oh, but then 1/4 of 16 is equal to 4. So 16% of 25 is equal to 4. Remember, if you swap them, you get the same answer. Finally, we have something that is called multipliers. Imagine the original price of something was, let's say, $5,000, okay? And then we say the price is on 15% discount. If it's on 50% discount, to find the new price, we can do it in one step only. We have to multiply 5,000 by something that's called multiplier. Now, if it's 15% discount, 100% minus 15%, that's basically equal to 85%. Remember, 85% as a decimal is 0.85. So if we only multiply this by 0.85, you will get the final answer. So this is what we call multipliers. Now imagine instead of discount, if we had, let's say, taxes added to the price. The price of something was $450, okay? And then we say we need to add 12% taxes on that. Taxes need to be added. So 450 will be multiplied by, remember, we start with 100%. Because these are taxes, we add 12%. So that will be 112%. And then as a decimal number, it's 1.12. The only thing we need to multiply is 450 by 1.12, and we find the total amount using something that's called multipliers. Enough with percentages, we move on to the next topic. Our new chapter is expressions. Let's start with simplifying expressions. So, by collecting like terms, what do we mean by that? Imagine we need to say, for example, what is A plus one more time A? A and one more A is equal to 2A, right? Now, what is, for example, 4A plus 11A? 4 of A's and 11 more of them will be equal to 15A. Excellent. What if it was multiplication? What if it was A multiplied by A? This is not equal to 2A, but is equal to A squared instead. Because here the exponent is 1 and here the exponent is 1. We add the exponents and we get 2. Imagine we had now 3A multiplied by 5A squared. Alright, what do we do in this case? Step 1, we multiply the numbers. 3 multiplied by 5 is equal to 15. And then A multiplied by A squared. Remember, the exponent here is 1. When it's multiplication, we only add the exponents. 1 plus 2 is equal to 3. That's it. Our final answer is 15a to the power of 3. Now, what if we have an expression where we need to collect like terms? For example, 4a plus 3 plus 4b minus 2a minus 11b. By like terms, we mean terms with same variable. So 4a has a term that has a as well. 4a minus 2a, 4 minus 2, 2a. Then we have it again. 4b minus 11b. We learned in this video that positive 4 and negative 11 will be negative 7b. Finally, there is a term that doesn't have any like terms. It's plus 3. So we just copy plus 3 to it. That's it. We have simplified this expression. Now, there is something that we call expanding brackets. If we have, for example, 5 and then multiply by 2x plus 2, for example. The way this works is there is an imaginary multiplication sign. 5 multiplies by 2x and 5 multiplies by 2. Now, what is 5 multiplied by 2x? 5 times 2 is 10, so it's 10x. And then 5 multiplied by 2 is equal to 10. That's it, we are done. Or let's try another expression. What if we have, for example, 3a multiplied by, let's say, b plus 2a plus 4. Okay, step 1, we would multiply 3a by b. 3a and b are not like terms, so we would only put them together. 3a multiplied by b will be 3ab. And then we have to multiply 3a by 2a. 3 times 2 is 6. So it's going to be 6. And then a times a. We learned it already. A squared. Finally, 3a multiplied by 4. 3a multiplied by 4 is equal to 12a. And that's it. We have expanded the brackets. Now we have something that is opposite to expanding brackets. It's called factorization. Imagine we say now 4a plus 12. Both 4a and 12 are divisible by one number. By what number are they divisible with? They are divisible by 4, right? So we copy 4 and then we open the brackets. Then you ask yourself, 4 multiplied by what will give me 4a? 4 times a is 4a plus, because here it says plus. Then you ask again, 4 multiplied by what will give me 12? 4 times 3 is equal to 12. So if this was called expanding brackets, then this is called factorization. Let's have one more factorization and then we move on to the next chapter. Imagine we say 3a squared minus 9a plus 15. Are they all divisible by something? Yep, they all are divisible by number 3. So 3 is the only thing that goes out. And then again, 3 by what will give us 3a squared? What we are missing is a squared. Then 3 by what will give us minus 9a? 3 by 3a will give us minus 9a. Finally, 3 by what will give us 15? 3 by 5 will give us 15. That's it. We have factorized this expression. Next chapter. Right, here we are, the next one, equations. So, whenever we start talking about equations, the idea is always to isolate the variable. Now, what do we mean by that? If we have, for example, x plus 5 is equal to 11, you ask yourself, wait, I want my x to stand alone, so I want to get rid of plus 5. What is opposite to plus 5? Minus 5 minus 5, right? So it's going to be x is equal to 11 minus 5 is equal to 6. That's it, we are done. Or what if it was, for example, 3x is equal to 15, let's say. Then you ask again, wait, the sign between 3 and x is multiply. Now, the opposite thing of multiplication is division. So divide by 3, divide by 3. X is equal to 15 divided by 3 is equal to 5. Great. What if we have this one? X over 5 is equal to 4. Then you ask again, I'm dividing by 5. The opposite thing to that is to multiply by 5. And that's how we get rid of that. So x is equal to 4 times 5, which is 20. Fine, but what if we have two-step equations? If we say, for example, 2x plus 5 is equal to 11. Then you say, wait, step 1, I need to get rid of plus 5. The opposite to plus 5 is minus 5. So it's going to be 2x is equal to 11 minus 5, which is 6. The next step would be to divide by 2 and divide by 2. X is equal 6 divided by 2, it is equal to 3. Great. Now what if we have an extra step? What if we have, for example, 3 multiplied by x plus 2 and then everything is equal to 11? Then here we say, wait, step 1 we have to expand the brackets, right? So it's going to be 3 by x, which is 3x, and then 3 multiplied by 2, which is 6, that is equal to 11. Now it's opposite to plus 6, which is minus 6. So 3x is equal to 11 minus 6, which is 5. Final step, divide by 3, divide by 3. X is equal to 5 over 3. That's it, perfect. And the last one when it comes to equations. What if we have an equation that looks like this? 4x minus 5 is equal to 3x plus 1, let's say. Now, it's very important to have variables on the same side and the numbers on the other side. So basically, I have 3x here. I want to move it to the other side. So I'm going to take it away, 3x and minus 3x from both sides. What does that mean? On the right side, 3x minus 3x, that goes away. So we have only 1. While on the left side, it's going to be 4x minus 3x, and then I copy minus 5. Why is that important? Because 4x minus 3x is equal to x, and then minus 5, and then 1. Lastly, we know already that opposite to minus 5 is plus 5. So x is equal to 6. So even if we have variables on both sides, it is pretty easy. Now, what if we have inequalities? Now, by inequalities, everything remains basically the same as with equations. So let's say we have, for example, x plus 5 is greater than or equal to 2, let's say. Step 1, we want to get rid of plus 5, right? So you would say minus 5 is opposite to plus 5. So x is greater than or equal, positive 2, negative 5 is negative 3. Perfect. Now, every inequality has to be represented on a number line. All right, a number that we need is a negative 3. Then we have a circle. Now, this circle can be either colored or it remains empty. It depends if your inequality has an equal sign underneath. So if you see the equal sign, then you will color the circle. Perfect. And finally, direction. Since it says go to the right side, we go to the right side, and this is the solution to our inequality. All numbers that are greater than or equal to negative 3. Let's have one quick example. If I say, for example, 5 plus 2x is less than 4. Again, in this step, I want to get rid of 5, right? So minus 5 and minus 5, which basically means 2x is less than 4 minus 5, that's minus 1. Lastly, we need to divide by 2, divide by 2. So x is less than negative 1/2. Again, we need to represent that on a number line. Negative 1/2, we have a circle. Our circle will remain empty because there is no equal sign underneath. Finally, this tells us the direction. We go to the left side. So all numbers that are less than negative 1/2. That's it with the chapter. We move on to the next one. Alright, our next chapter is a pretty short one, but a very important one. So it's ratio and proportions. Let's say we have, for example, 3 cups of flour for 10 cups of water. Now, we need to write this as a ratio. So, 3 flour to 10 of water. It's very important that we know the ratio can be written in multiple different ways. It can be written as 3 to 10 flour to water, or it can be written as a fraction as well, 3 over 10. Or it can be written as a decimal number, 0.3, because 3 over 10 is 0.3, right? Flour to water. And finally, it can be written as a percentage as well, because 30% of the total amount, of the total mass, is flour. So here are some amounts. Then it's very important to say that ratio has always to be written in simplest form. So when we say, for example, 6 over 15, is this ratio written in simplest form? It is not. Why? Because 6 and 15 can be divided by 3, right? So the answer will actually be 6 divided by 3, which is 2, and then 15 divided by 3, which is 5. The ratio is now written in simplest form, and it is 2 to 5. What if we have to write, for example, this ratio in simplest form? 45 minutes to 1 hour. We need to write this in simplest form. So basically we say 45 minutes to 1 hour. But tell me, what is 1 hour in minutes? It's 60 minutes. Now what is that as a ratio? We notice that this can be divided by 5, by 3, but it can be divided by 15, right? Both of them. So we basically have 45 divided by 15 is 3, 60 divided by 15 is 4. So this ratio in simplest form is 3 to 4, or 3 over 4. And then when it comes to proportions, proportions are usually given in this form. A over B must be equal to C over D. Now, if we have an example of 1 over 5 is equal to M over 8, for example, what is M equal to? What basically works every single time is cross multiplication. Alright, M multiplied by 5 is 5M, and then on the other side 1 multiplied by 8 is 8. Doesn't this look like equations that we solved a couple of minutes ago? We divide this by 5 and we divide this by 5, so the final answer is equal to 8 over 5. So 8 over 5 is our answer. Alright, here are proportions. That's it. See you in the next chapter. Chapter is here. Now we talk about slope and then intercepts of a line. Okay, we have something like this. Y is equal to mx plus b. Now, y is equal to mx plus b is an equation of a straight line that is given on the coordinate plane. So, if we have, for example, y is equal to x, or let's say 2x plus 1. That's basically it. Y is equal to mx plus b. Now, if you want to plot this on the coordinate plane, what is enough is 2 points only. Now, which 2 points? It's up to you. You can decide. I would personally say you can always get 0 and 1. Alright? So, let's put 0 for x. 2 times 0 is 0. and then 0 plus 1 is 1. Alright? Then we do the same thing with 1. 2 times 1 is 2, plus 1 is 3. Okay, our first point is 0 for x and 1 for y. 0 for x and 1 for y, here it is. Then our second point is 1 for x and 3 for y. 1 for x and 3 for y. Here it is. So 2 points were enough to graph the equation of this line. Now, it's very important that you know the number that you see that stands before x. We call it the gradient of a line. The gradient of a line. Another name for that is a slope of the line. Now, what does the gradient stand for? I mean, how does that help? Now, in real life, the higher the gradient is, the steeper the line is. So if it was, instead of 2x plus 1, imagine it was 5x plus 1, then this is how the line would look. So, or actually, it would be better if we represent it on the same coordinate plane. So, 5x plus 1 would be a steeper line. Let's say a line like this. Or imagine instead of that we said y is equal to 10x plus 1. Then it would be even steeper. Then that line would look like this. Alright? So the higher the gradient is, the steeper the line is. Okay? Then the number that's after that, the variable, the number that comes without the variable is called the y-intercept. The y-intercept. That's basically the place where we intersect the y-axis, right? So for us, the y-intercept was 1, right? But then when we plot this on the coordinate plane, we draw the line that passes through point 1 on the coordinate plane on the y-axis. So this number tells us that we cut the y-axis at point 1. Now, this form of a line, y is equal to mx plus b, is called slope-intercept form. We just had an example. Y is equal to 2x plus 1. We know that our slope, or we said another name for slope is gradient, is equal to 2. And 1 is our y-intercept. But what if we have an equation that looks like this? Y is equal to x plus 4. There is no number here, but that means it is 1, right? So you can imagine that it was 1x. So the slope is 1. And then what does 4 stand for? That is our y-intercept, the place where we intersect the y-axis. Or lastly, what if it was y is equal to 3x only? Now we say, 3 is our gradient, which means our slope. But then what's the y-intercept? Where is it? Do you see it? No. You can imagine here it was plus 0. So 0 is the place where we intersect the y-axis. And lastly, from this chapter, I will give you formula how to find the slope of any line. This slope in this formula, y is equal to mx plus b, can be found by using this. M is equal y2 minus y1 over x2 minus x1. But then what are x1, y1 and x2, y2? Those are any 2 points from the coordinate plane. So let's say here is our line. One point is here, and this point has coordinates x1, y1. And then there is another point on that line, this point here. It has coordinates x2, y2. If you put the values in this formula, you can find the slope of the line. If you need more help with this, find a video on my YouTube channel where I go into deep and explain how to find the slope of a line and how to deal with x-intercept, y-intercept, and so on. That's it in this short review. We move on to the next chapter. And now we start with geometry. And lastly, there is geometry. So, when it comes to geometry, what's important is that we cover the basics first. By basics, I mean this. Yep, so here is the list of 5 basic shapes that you should know by the end of your middle school. So we have a triangle, we have a square, we have a rectangle, a circle, and a parallelogram. Now, when we talk about these shapes, the main two things that we need to find is a perimeter of your shape and area of your shape. So for example, if we have a triangle to find, or of any other shape, to find the perimeter of your shape, that basically means to find how long the edges are. So for example, if we have a triangle, this one here, and then we say, okay, this side here is 6 centimeters long, this side is also 6 centimeters long, and this one is 6 centimeters long. Now, what we have for the perimeter is equal to 6 plus 6 plus 6, which is basically equal to 18 centimeters if we talk about centimeters. Now, perimeter means to find the sum of the lengths of all the edges of your shape. Alright? The same thing works for a square, a rectangle, circle, and a parallelogram. Now, when we have a square, that means that all sides are equal, and when we have a rectangle, it means that opposite sides are equal. Alright? Then we have a circle. We will talk about circles in a second. And then we have parallelograms. Now, the difference between rectangles and parallelograms, still, opposite sides are equal and parallel, but in a rectangle, we have 4 right angles, 4 angles of 90 degrees, while in a parallelogram, only opposite angles are equal, but they're not right? If the angles are right, then we have a rectangle. So we can say that rectangle is a special parallelogram. Now, how do we find the area of all of these shapes? To find the area of a triangle, there is something that we call, so it's base times height divided by 2, right? Now, what are base and height? For example, for this triangle here, we can say that this side is our base, all right? Now, what's the height? Height is that one, the length that is from the opposite vertex to the base, but then under 90 degrees. So we call it a height. So base times height divided by 2. And that's how we find the area of a triangle. Okay, what do we have next? We have a square. We know that in a square, all 4 sides are equal. So to find the area of a square, you basically have to multiply side by side, okay? Or we can basically say it's side squared if our side has a length of a. All right, a squared. Then we have a rectangle. The same thing works for a rectangle. So if this length here is a and this length here is b, then the area of a rectangle would be a times b. And that's it. So we just multiply length by width. All right. When we have a parallelogram, it's the same thing as a rectangle, as a triangle, but we do not divide it by 2. Because basically our parallelogram has 2 triangles, right? So area of a parallelogram is base times height. Here is our base, and this one is, let's say, our height. There are different heights here. We can talk about that in one of the next videos. Finally, we left circle out. So, to find the area of a circle, let's say I will draw the shape one more time. There it is. We have a circle. Now, to find the area of a circle, there is something that we call radius of a circle. Radius of a circle is the distance from the center of the circle to the circle. Alright? So the area of a circle is equal to radius times pi. Oh, by the way, if you haven't heard of pi, pi is a constant that is equal to 3.14 and so on. It's an irrational number and it has infinitely many digits. So remember, area of a circle is radius times pi, or we can basically say radius squared times pi. Now, to find the perimeter of a circle, in different way, we call it circumference of a circle. Circumference of a circle. And that is equal to 2 times radius times pi. So instead of saying radius times pi, we say 2 times radius times pi. Excellent. Now, the last thing about circles that we'll mention in this video is the length from one point on a circle to another point on the circle is called diameter. And then what is diameter equal to? We said from the center to the circle, it's radius. From the center to the circle, it's radius. Now, if we combine two radii together, we call it diameter. And diameter is basically equal to 2 times radius of a circle. So basically, speaking of basic shapes, that's all we need at the moment. Now, let's talk about angles. We find angles very important in middle school. Now, there are three main types of angles. We can say that if our angle is, let's say, if our angle looks like this, then we call it an acute angle. So, acute angle is an angle that has less than 90 degrees. If our angle has exactly 90 degrees, then we call it a right angle. So right angle has exactly 90 degrees. All right? Now, what if our angle has more than 90 degrees? So if our angle looks like this, for example, then we call it an obtuse angle. So obtuse angle has obtuse angle has less than 180 degrees, but more than 90 degrees. For example, if our angle has 120 degrees, then we call it an obtuse angle. Alright, but we have reached the point of 180 degrees. What if our angle has exactly 180 degrees? Then we call it a straight angle. So a straight angle has exactly 180 degrees. Fine, but what if our angle has more than 180 degrees? Then we call it a reflex angle. So a reflex angle has more than 180 degrees. And finally, a full circle would be an angle that has 360 degrees, right? So 360 degrees, we call it a full circle. Now, what are some relations between angles? Let's say we have two lines, and let's say we have these two lines that are parallel. Now, if we intersect the two lines by a third line, then this line that we are intersecting them with is called transversal. Okay? Let's say this is our line A, line B. They're intersected by a third line. That line is called a transversal. Now, if lines A and B are parallel, then we have some different relationships between angles. So, what do you notice here? Let me mark them with numbers 1 to 8. Alright, now that we have marked them from numbers 1 to 8, what do we notice here? If the lines are parallel, then angle 1 and angle 5 are equal, right? So, angles 1 and 5 are called corresponding angles, and corresponding angles are equal. All right, so corresponding angles are equal. Angles 1 and 5 corresponding and they're equal. All right. Now, what other angles are also corresponding? Angles 2 and angle 6 are corresponding and they're equal. Angle 4 is corresponding with angle 8. They're equal. Angle 3 is corresponding to angle 7 and they're equal. So these are called corresponding angles. Other than corresponding angles, we have cointerior angles. Now, what are cointerior angles? Angles that are on the same side of a transversal are called cointerior angles. Cointerior angles. So angles 4 and 5 are cointerior. What's interesting about them? Are they equal? Nope. We say that they add up to 180 degrees. So cointerior angles add up to 180 degrees. Lastly, we have something that's called alternate interior angles. Alternate interior angles are angles that are on opposite side of a transversal. So for example, opposite side of a transversal, let's say angle 3 and angle 5 are on opposite side of a transversal. So we say that angles 3 and 5 are alternate interior angles. All right. So we have learned, and what do we know about alternate interior angles? They are also equal. So basically, in this part, we have learned about corresponding angles. They're equal, angle 1 and angle 5. Then we have learned about cointerior angles. They add up to 180 degrees. Angles 4 and 5, and also angles 3 and 6. Finally, we have learned about alternate interior angles, angles that are on opposite side of a transversal, and they are also equal. They are equal. All right. And for the last part, we have Pythagoras. So you can hear Pythagorean Theorem as well. That theorem is used if we have a right angle triangle. So if we have a triangle that has one angle that is right, remember, right angle, 90 degrees. Then in this right angle triangle, sides A and B are usually called legs, okay, shorter sides, and side that is opposite to this angle of 90 degrees, the longest side, is always called hypotenuse. Now, there is a theorem from a famous mathematician that basically allows us to find the length of the remaining side of side C using sides A and B that are given. And the theorem, the formula says C squared is equal to A squared plus B squared. So using this formula, you can always find the length of the longest side, but you can also find the legs of the other sides. So for example, if we have a triangle that has side lengths of, let's say, a right angle triangle, okay, it has side lengths of 3 and 4, and this one here is question mark. Now we recognize, okay, we have a right angle triangle. The shorter two sides are 3 and 4, so we can basically say A is equal to 3, B is equal to 4. Now, how do we find the remaining side? We will mark it with C, and then C is equal to question mark. Side C is our hypotenuse, right? So we apply the formula and we say C squared is equal to A squared, for us that's 3 squared, plus B squared, for us that's 4 squared, which means that C squared is equal to 3 squared, 3 to the power of 2 is 9, and then we have 4 to the power of 2, which is 16. So basically C squared is equal to 25, but remember, this is C squared. Now, to find C only, you would have to find the square root of 25. What number multiplied by itself will give us 25? It's 5. So C is equal to 5. And that's how we apply the Pythagoras to find the side length, the missing side length. In this case, it's missing hypotenuse. But imagine this question looked like this. In our triangle, a right angle triangle, Hypotenuse is given it's 5. This side is given it's 4, and this side here is question mark. Now again, we apply the Pythagoras and we say 5 squared is equal to 4 squared plus, now this one you can mark it with x or with a, whatever you find easier. Let's say x squared. Let us solve the equation. 5 squared, 25. 4 squared, 16 plus x squared. We have learned in this video already that we say minus 16 and minus 16, right? So we get that x squared is equal to 9. And then one more time, this is x squared. To find x, we basically just have to find the square root of 9, and that is equal to 3. So the missing side is 3. And that's it. So basically using Pythagoras, you can always find either the sides of the length of hypotenuse, or you can find the length of any other side. Now, more questions and more practice on Pythagoras you can find in some of the videos on my YouTube channel. And basically with that we have covered everything we promised we will cover in middle school math. We have covered all 10 chapters, and then whatever you find interesting and important, you can watch one more time and then revise, learn it, and prepare it for your exams. And we said it will take us 30 minutes. It took us a bit longer, but as long as you understood everything, I hope that was good enough. Now for the end, I would like to ask you to like the video and also to subscribe my YouTube channel so that you can watch more videos like this. I will see you in the next video. That's it for today.